Good morning, all. This is Aishwarya, final semester MSc at Physics student of Regional Institute of Education, Mysore. Here I am going to discuss about Introduction to Nanotechnology. Come, let's start. What is the difference between science and technology? Science, it is a methodical way of gaining knowledge on a particular subject through observation and explanation. Basically, science is gaining knowledge. There are many branches of science: chemistry, physics, biology, etc. Whereas in technology, it is the practical application of scientific knowledge for various purposes. Suppose study of X-rays comes under science, and the X-ray scanning which is happening in hospitals, that comes under technology. Science does not change with time, but technology changes with time. Material science. Material science is an interdisciplinary field that focuses on understanding the properties and behavior of materials, as well as developing new materials with specific desired properties. It encompasses aspects of physics, chemistry, engineering, and biology to study the structure, properties, processing, and performance of materials. The ultimate goal of material science is to tailor materials to meet the needs of various applications, ranging from electronics and energy storage to healthcare and transportation. Some of the materials can be grouped into metals, ceramics, polymers, glass, and composites. What is this? Yes, this is a nano car. Ratan Tata launched this car. This was one of his dream project. Have you ever wondered why this car named Nano? What is nano? The word nano is a prefix derived from the Greek word nanos, meaning dwarf or small. Nano generally denotes a factor of 10 raised to minus 9 or 1 billionth. Since it's a small car, it's called a nano car. It's named as nano car. Nanotechnology. What is nanotechnology? It's a field of applied science focused on design, formation, identification, and application of materials and devices on nanoscale. As in the world of materials, there has been a considerable activity in finding and devising newer material which will have extraordinary properties. The need to engineer nanomaterials for a particular interest and used in commercial product like cosmetic and also food preservatives. So basically nanotechnology, it is a design, production, application of systems, devices and structures by controlling shape and size at nanoscale. Nano pioneers. What is nano pioneers? Pioneer meaning person first among all to find something new or explore new things. So here's Mr. Richard Feynman, physicist. He is the father of nanotechnology and a Nobel Prize winner in 1965. Nanotechnology was founded by Richard Feynman. It all began with a talk titled "There is a Plenty of Space at the Bottom" by the physicist Richard Feynman at an American Physical Social Conference on December 29, 1959, long before the word nanotechnology was used. What is the meaning of plenty of room at the bottom? It means that things can get a lot smaller than they are now and still work. So let's see how small we can make them. Here's Mr. Norio Taniguchi. He coined the term nanotechnology in the year 1974. History of nanotechnology. The first ever concept was presented in the year 1959 by the famous professor of physics Dr. Richard Feynman. Invention of scanning tunneling microscope in 1981 and the discovery of fullerene in 1985 lead to the emergence of nanotechnology. The term nanotechnology had been coined by Norio Taniguchi in 1974. Nanomaterial. What is nanomaterial? We learned just now nano means small or dwarf. So nanomaterial means small material. Let's see what is nanomaterial. These are the materials with at least one external dimension in the size range of 1 to 100 nanometer. These material possesses unique properties and behavior compared to their bulk counterparts due to their small size and high surface area to the volume ratio. Materials with structure at nanoscale often have unique optical, electronic, thermophysical and mechanical properties. They are also subdivided into nanocrystals, nanopowders and nanotubes. So basically, nanomaterials are the set of substance where at least one dimension is less than approximately 100 nanometers. The chemical and physical properties of solid materials strongly depend on size and the shape of small particles. The natural sources of nanomaterials include volcanic ash, combustion products of forest fires, ocean sprays formed directly from the oceans, etc. Engineered nanomaterials designed or fabricated with very specific purposes and properties related to shape, size, surface properties, and chemistry. Some of the examples are carbon nanotubes, quantum dots, etc. Here is a picture of a nanoscale and the materials coming under this. You can see atom at one end which have a size of 1 angstrom, which is 10 raised to minus 10 meter. Then comes molecules which is having 1 nanometer size. Then comes DNA which is having 10 nanometer of size. Then viruses which is having 100 nanometer size. Just now we learned that materials coming under 1 nanometer to 100 nanometer is called nanomaterials. And we have bacteria which have size of 1 to 10 micrometer. Then we have a human hair strand which is having 100 micrometer and so on. Here particular figure you can see a lot of everyday life example of nanoscale things, nanoscale materials. Here we can see scale of nanometer and more. Here we have natural things, also man-made things. Coming to natural things, first we can see a dust mite, a scale of 200 micrometer. Then here we can see a ant, feet of the ant is almost 5 micrometer. This side we can see a hair strand of diameter almost 60 to 120 micrometer. And also in this side we have fly ash of 10 to 20 micrometer. And we have red blood cells with white cells 10 7 to 8 micrometer. And we have DNA here 2 nanometer in diameter. And coming to the man-made things, we have head of a pin which is having 1 to 2 millimeter. Then in the end we have nanotubes, carbon nanotubes which is having diameter of 2 nanometer. Uh, we can grow nanotubes in laboratory of typical size. So these are some examples of natural things and man-made things in a nanoscale and more. Types of nanotechnology. Here I will be giving a brief idea of what are the types of nanotechnology. First one is descending, that is top down. It involves the breaking down of large pieces of material to generate the required nanostructure from them. This means that we take heavy objects and cut into smaller and smaller until we reach a nanoscale objects. Next is ascending, that is bottom up. Here you start with a nanometric structure, a molecule for example, and through a mounting of self-assembly process, you create a larger mechanism that one you started with. So bottom-up method is suppose an atom we put together until we reach a nanoscale object. Like add atoms side by side to attain a nanoscale object. Next is dry nanotechnology. It is used to manufacture structures in coal, silicon, inorganic materials, metals and semiconductors that do not work with humidity. Next is wet nanotechnology. It is based on biological system present in aqueous environment. It includes genetic material, membranes, enzymes, and other cellular components. Engineered nanomaterials. These are materials designed at the molecular level to take advantage of their small size and novel unique properties which are generally not seen in their conventional bulk counterparts. The two main reasons why materials at the nanoscale can have different properties are: first one is increased relative surface area. Second one is quantum effects at nanoscale. Nanomaterials have much greater surface area to volume ratio than their conventional forms, which leads to greater chemical reactivity and hence affect their strengths. At the nanoscale, quantum effects determines the material's property and characteristics, which leads to different optical, electrical and magnetic behaviors. Just now we discussed surface to volume ratio increases. What happens if surface to volume ratio increases? As surface to volume ratio increases, a greater amount of substance comes in contact with the surrounding material. This results in the better catalyst since a greater proportion of the material is exposed for potential reaction. This picture depicts the application of nanoparticles and nanomaterials. Nanomaterials are crucial for the utilization of their diverse application. We have many real-life applications for the nanomaterials. Here are some of the examples. Nanomaterial is useful for healthcare, environmental protection, energy sources, agricultural and food, consumer goods, construction and smart cities. It's also used in electronic in machines and it's very useful in biomedical researches. Now we'll discuss more about the application. Some examples and applications of nanotechnology. Nanotechnology and nanomaterials can be applied in all kinds of industrial sectors. They are usually found in these areas. First one is electronics. Carbon nanotubes are close to replacing silicon as a material for making smaller, faster and more efficient microchips and devices as well as lighter, and more conductive and stronger quantum nanowires. Graphene's properties make it an ideal candidate for the development of flexible touchscreen. Next application is energy. A new semiconductor developed by Kyoto University made it possible to manufacture the solar panels that double the amount of sunlight converted into electricity. Nanotechnologies are cost lower, products stronger and lighter wind turbines, improves fuel efficiency, and thanks to the thermal insulations of some nano components. These can save energy. Another application of nanotechnology is biomedicine in medical field. The properties of some nanomaterials make them ideal for improving early diagnosis and treatment of neurodegenerative diseases or cancer. They are able to attack cancer cells selectively without harming other healthy cells. Some nanoparticles have also been used to enhance pharmaceutical products such as sunscreen. And the application environment. Air purification with ions, wastewater purification with nanobubbles or nanofiltration systems for heavy metals are some of its environmental friendly applications. Nanocatalysts are also available to make chemical reaction more efficient and less polluting. Another application of nanotechnology is in textile industry. Nanotechnology makes it possible to develop smart fabrics that don't stain nor wrinkle, as well as stronger, lighter, and more durable. Another application is in the field of food. In this field, nanobiosensors could be used to detect the presence of pathogens in food or nanocomposites to improve food protection by increasing mechanical and thermal resistance and decreasing oxygen transfer in packaged products. Medical application in nanotechnology. There are two fields, research and clinical. Now let's see the medical application in nanotechnology. First one is drug screening. Drug screening is a process by which potential drugs are identified and optimized before selection of drug to progress clinical trials. Next application is gene delivery. Gene delivery is a process by which foreign DNA is transferred to host cells. Next application is diagnosis. Coming to clinical, it's drug delivery. Drug delivery refers to process of administering therapeutical agents such as medication or pharmaceutical drugs into the body to achieve a desired therapeutical effect. Another application is detection and diagnosis monitoring. These are the major medical applications of nanotechnologies. Nanotechnology in future. How nanotechnology in future change the world? Let's see. There are bright and dark spots in the future of nanotechnology. On one hand, the sector is expected to grow globally, driven by technological advances, increased government support, increased private investment, and growing demand for small devices. However, the environmental health and safety risks of nanotechnology and concerns related to its commercialization could hamper the market expansion. So these are the basic idea of what is nanotechnology and the application of nanotechnology. Thank you.